All right, guys, today we're going to be talking about the chain rule, and it is, in my opinion, literally the most important single rule on the AP Calculus exam. Something crazy like 15% of the AP Calculus exam includes the chain rule somewhere in it. And what the chain rule involves is functions that are inside of other functions. So let's make sure we're all on the same page about composite functions. So we're looking for two functions, h of x and g of x, such that the original function can be written as h of g of x. That means g of x is inside of h of x. So let's see how you guys do on this first one. What would h of x be and g of x be, so that you can think of it as g of x inside of h of x? And so here, the outside function, this is the outside function, is going to be x squared. We can see this is like something. We can think of it as like y squared. And so h of x will be x squared. And g of x is the thing that's inside of this square function, the y function, the inside function, and it is x cubed plus 1. So then h of g of x means that g of x goes inside of h of x. It goes in for x here. So this becomes x cubed plus 1 squared. Okay. Same deal on this next one. So what are a function h and g so that you can have an inside and outside function? So here, h of x, the outside function, and g of x, the inside function. I often find it easier to start with what is the inside function, what's the thing that's inside of another function. So here, clearly x cubed plus 1 is inside of another function. So what is it that's inside of another function? Well, 2x is inside of another function. And what is that function it's inside of? It's inside of e to the x. If you put in 2x in for x here, it'll say e to the 2x. And so h of g of x would be e to the 2x. How about this next one? If y equals square root of 4x plus 5, what is h of x, the outside function, and g of x, the inside function, so that we can rewrite this as h of g of x? Again, the inside function is often easier to see. The inside function is 4x plus 5, and that is inside of the function square root of x. So if we put in 4x plus 5 in for x, it would say square root of 4x plus 5. So that says h of g of x, the composite, is square root of 4x plus 5. Okay. Last one, y equals sine cubed of x. What is the outside function and the inside function? Well, this might be a little harder to see. The thing that is inside, again, I think it's easier to start with the inside function. The thing that's inside of another function is sine of x. And what it's inside of is it's being cubed. So x cubed is the inside function, and when we plug it in, it would say sine of x cubed, and the way we write sine of x cubed is sine cubed of x a lot of the time. So I hope we recognize that that is what's going on there. So that is h of g of x. Okay, now for each of these functions above, find h prime of x and g prime of x. So for h of x equals x squared, h prime of x, this is in part A, h prime of x equals 2x, we just do the power rule. G prime of x equals, we just do the power rule, 3x squared. For B, h prime of x equals, this is now our e to the x, we should know. E to the x, the derivative is e to the x still. How about g prime of x? What is the derivative of 2x? Well, it'll just be 2. The derivative of x is just 1. C, the derivative of square root of x, this one's a little harder. So h of x, I'm going to rewrite it. This is a power rule, it's just hidden. This is x to the 1/2 power. And so h prime of x is 1/2 x. We multiply by the power, and we lower the power by 1. So I'm going to subtract 2 over 2, because that's subtracting 1. So it'll be to the negative 1/2 x. And this is 1 over 2 square root of x, because a negative exponent means it's in the denominator, and a fraction of 1/2 means it's the square root of x. So So 1 over 2 square root of x. By the way, it's probably worth memorizing the square root of x. You know, you need to be able to do all kinds of roots, but just like memorizing this comes up like, it'll come up like 40 more times this year. So if you memorize it once, it'll save you a lot of time. And what about g prime of x? The derivative of the inside function is, the derivative of 4x plus 5 is just 4. The derivative of a constant is 0, and the derivative of x is 1, so 4 times 1 plus 0. Lastly, d, what is the derivative of x cubed? Well, that's power rule, 3x squared, that's h prime of x. And the derivative of g of x is cosine of x. The derivative of sine of x is cosine of x. So hopefully we're feeling good about composite functions, how to rewrite. I hope you are really familiar with this from pre-calculus, and if not, I hope our homework after the test, you know, got us to the same place. So again, this rule we're doing today comes up super often. It's really useful and helpful. It's going to make our lives easier in a lot of ways. So let's get into it. So a function, f of x equals sine of x squared. This isn't just a sine function, and it's not just a quadratic function. This is called a composite function. It has a function, composite function. X squared is called because it's inside of another function, it's called the inside function. And the sine, I guess I need to write function here, the inside function. And the sine function has something inside of it, and it's called the outside function. And of course, the outside function operates on the answers to the first function. So if you plug in a number here, so like if you wanted to do f of 3, what you would do is you do sine of 3 squared. You do the answer to 3 squared, and then you do sine of that answer, which is, that can't be simplified, but you know, you get the point. So we always work from the inside of the function out when we're evaluating. Let's identify the inside and outside functions here. Hopefully you're feeling pretty comfortable with it. What is the inside function here? The inside function is 3x. It's inside of what function? Sine of x. If you plug in 3x into x, it would say sine of 3x. How about here? What's the inside function? I think we had this one in our warm-up. The inside function here is sine of x, and the function it's inside of is x cubed. If you put in sine of x into x cubed, it'll say sine of x cubed, which is sine cubed of x. Notice that is different from this one. Here, what is the inside function? Well, now x cubed is inside of sine of x. So hopefully we can see the difference there. All right, here, what is the inside function? This is 2 to the cosine of x. The inside function is cosine of x. And the function it is inside of is 2 to the x. We could do 2 to the cosine of x. How about here? What's the inside function? Well, secant of x. And the derivative and the outside function is natural log of x. So if we plug in secant into x, it'll say natural log of secant of x. Our last one here is, what's the inside function? Well, 3x minus 2 is inside of what function? X to the 4th. If we put in 3x minus 2 into here, it would say 3x minus 2 to the 4th power. So hopefully we're feeling good about these. And now we are going to look at what the chain rule actually says. Okay? The chain rule says if you have a function that is a composite function, that is f of g of x, then the derivative is, you do the derivative of the outside function, leaving the inside function alone. And then at the end, you just multiply times the derivative of the inside function. So you do the derivative of the outside function with the inside function plugged into it. And then you multiply that answer times the outside function. So let's look at how this works on some of these kind of easy ones up above. So remember, we had f of x and g of x here. We had our inside function and outside function. And in our warm-up, I asked you to find the derivative of the inside and the outside function. We're going to use both of them. So the outside function, the derivative is the derivative of sine of x is cosine of x. The inside function, the derivative of 3x, is 3. And the way the chain rule works is it is the derivative of the outside function. So cosine, but not with an x there. So we will replace this with the inside function. That's what the chain rule said. It said we do the derivative of the outside function, but with the inside function plugged into it. And the inside function is 3x. And then we will multiply times the derivative of the inside function. And we'll usually put, a lot of times we'll end up with constants here, and the constants will always come to the front. So 3 cosine of 3x. So this should kind of make sense, right? The derivative of sine is cosine, and we leave the 3x inside of it. Whatever was inside the inside function, we leave it there. We don't ever change what was inside of the function. And then we multiply times at the end what the derivative of the inside function was. So we do the derivative of the outside function with the inside function left alone, and then at the end we multiply times the derivative of the inside function. Okay, let's see how this looks for the next one. So this next one, the derivative of the outside function is 3x squared, but we're not going to put an x there. Instead, what's going to go inside of it is the inside function. So the inside function was sine of x. And we can write this as sine squared of x. That's how we would usually write it. So it's the derivative of the outside function would be 3x squared, but in the x is still the inside function. Okay? So 3x squared, but instead of x, we put in the inside function, times what is the derivative of the inside function? The derivative of the inside function is cosine of x. So this will always end up being multiplied at the end. Oftentimes we'll write this as 3 sine squared of x times cosine of x. It's like the common way to write it. Okay. I want you guys to try this one on your own. Here, the outside function is sine of x. So what are we going to do here? What's h prime of x? Well, the derivative is, we do the derivative of the outside function, which is cosine of x, but with the inside function still plugged in. Then we multiply times the derivative of the inside function. So the derivative of x cubed is 3x squared. Usually constants and polynomials will come in the front, so we can put like 3x squared cosine of x cubed, but this is just a style thing. If you left it like this, it wouldn't be wrong, it just wouldn't be like the way we normally write it. This is how any multiple choice answer would be written. So that's a thing to realize. Okay, guys, let's do one more. I want to let you guys try one more on your own. How is this going to work? Well, we do the derivative of the outside function. So the outside function is something to the 4th power. And so the derivative will be 4 times whatever that inside function was, cubed. So instead of an x here, it's just going to stay the inside function. Times, at the end, we have to do the derivative of the inside function. Okay? Oh, no, you guys couldn't see that. That's so terrible. Oh, no. I hate this. Okay, let's look at that again. So, again, we were doing the derivative of the outside function is 4 times, we're going to leave the inside function inside of it, cubed. So instead of 4x cubed, we have 4 times the inside function cubed, times the derivative of the inside function. And these can be combined because it's 4 times 3, and that'll go to the front. So 12 times 3x minus 2 cubed. And you can really see, like, it kind of makes sense. Look, okay, this is something to a power, so it's going to be 4 times that something to a power that's lower by 1. And you just leave whatever was inside of here. That's going to be the thing that's inside of it here too, but we also need to multiply times the derivative of the inside. Okay, with that in mind, it's time for you guys to practice some. And I want to move my, give me a second, I want to move my phone some so I think I'll do a better job of not being off the page if I can do this later. Okay, so let's see how you guys do for this. So I recommend writing what the inside function is and what the outside function is. But if you don't need to, this is not necessary. So the inside function is 5x squared. The outside function is sine of 5x squared. Okay, so the derivative, f prime of x, would equal what? Well, it's the derivative of the outside function with the inside function left inside of it. So we do the derivative of sine of x, and we leave the inside function alone inside of it, times the derivative of the inside function. And we usually write the 10x at the beginning. So 10x cosine of 5x squared. You can't move what's inside of cosine to the outside, but this multiplying, you can multiply either at the front or at the back, and the standard is to take polynomials and multiply them in the front. Same with constants. Okay, how about this next one? Think about the in and the outside function. So the inside function is 3x squared minus 2x, and the outside is sine of x again. You can really think of it as sine of something. I like to think of it like that. And so the derivative is, we do the derivative of the outside function, cosine of, and we're just going to leave the thing that's inside of it alone, 3x squared minus 2x, times the derivative of the inside function. Now we need to be really careful here. This is a sum or difference, and so when we multiply, it's going to be multiplying times a binomial, and I need this parentheses here. If you don't put the parentheses, it's just wrong. And I can move this to the front if I want. So 6x minus 2 times cosine of 3x squared minus 2x. This has to be in parentheses because it's a binomial and it will distribute. So that's what's going on there. All right, try this one on your own. What is f prime of x? Well, hopefully we can see this as something to the 4th power. And so the derivative of something to the 4th power will be 4 times that inside function left alone inside, times the derivative of the inside. So 4, oh wait, what am I doing? I already did that. I'm doing this derivative. So this is power rule, and it's a sum or difference, so it'll be two things. I have to have a parentheses here. So this will be 6x squared minus 4. There isn't really anything that simplifies easily here. These are just a bunch of polynomials multiplying together, so it's fine to leave it like this. If I really wanted to, I could distribute the 4. I cannot multiply the 4 inside of here because this is being cubed, but since this isn't being cubed, if I wanted to, I could multiply the 4 times this and get something like 2x cubed minus 4x cubed times 24x squared minus 16. So notice I can multiply the 4 times this one, but I couldn't multiply the 4 times this one because this one's being cubed. Okay. Okay, this one is a little funny. What is I'm going to go over this a little bit more slowly. Well, the inside function is pretty clearly 4x plus 1, and the outside function is square root of x. So how do we do the derivative of the outside function? Well, how do we do the derivative of the square root of x? Well, that's just a power rule one. So the square root of x is x to the 1/2 power, and the way we do the derivative is we multiply by the power and lower the power by 1. So 1/2 minus 2/2 is negative 1/2. And we can simplify this as 1 over 2 square root of x. Okay, so the derivative of the outside function is going to be 1 over 2 times the square root of, with the inside function still plugged in it. So 2 square root of 4x plus 1. Okay, so that's the derivative of the outside function with the inside function still inside of it. So the derivative of square root of x with 4x plus 1 still inside of it, times the derivative of the inside function. So the inside function was 4x plus 1, and we multiply times 4. Whenever we end up with like a fraction like this 4 can be thought of as 4 over 1, and it'll end up multiplying times just the numerator. So it's 4 over 2 square root of 4x plus 1. And oftentimes we'll be able to simplify here. So we can divide by 2 and divide by 2 and get 2 over square root. We don't have to put the 1 in the denominator here. 2 over square root of 4x plus 1. So this is like the simplified version. Okay, why don't you guys try one of these fraction-y ones, or the square root-y ones on your own. So the inside function is obviously x squared minus 4, and the outside function is the cube root of that inside function. And so I'm going to do this on a separate sheet of paper because I'm running out of room. So the derivative of a cube root, that's x to the 1/3 power, and the derivative is 1/3 x to the negative 2/3. And we can rewrite this as 1 over 3 cube root of x squared, because the fraction tells us what root it is. So the denominator is the cube root squared, and the negative exponent tells us it's in the denominator. Okay, now what's there? It's not x. X isn't what's there. It's the inside function is still going to be there. So this is going to be, it's going to be 1 over 3 cube root of the inside function squared. So this is the derivative of the outside function, the derivative of the cube root of x with the inside function still inside of it, times the derivative of the inside function. I don't need parentheses here because when I do the derivative, it won't be a binomial because this one will go to 0. If this had been 4x, I would need a parentheses here, but since it's not, I can just put times 2x, and that's good enough. And just like before, this can be thought of as 2x over 1, and so the 2x can go on top. So this is 2x over 3 cube root of x squared minus 4 squared. Yikes, those ones are a little bit long. Okay, another one on your own. This one's a little bit easier. The inside function is 5x minus 2, and the outside function is it's something cubed. So the derivative of the outside function of something cubed is 3 times something squared. So when we multiply times the 3, we'll get 12 times this thing squared, and the thing that's in there is now still we always leave the inside function alone. So you can see how it multiplied by 3, lowered the power by 1, and left the inside function inside of it, times the derivative of the inside function. And the derivative of 5x minus 2 is just 5. This can be simplified because we have a constant times another constant. And so this is 60 times 5x minus 2 squared. We do have a mastery quiz coming up on this next class, just be aware. So what's the inside function? The inside function is cosine of x, and it's getting cubed, so that's the outside function. So the derivative is going to be the outside function. We have to do the derivative. It's something cubed. The derivative of something cubed is 3 times that something squared. We don't change what the thing is inside of it, times the derivative of the inside function. The derivative of cosine is negative sine of x. And this can be moved. We can multiply it doesn't matter if the sine of x is in the front or the back, but we do need, because it's multiplying by a negative, we can do 3 times negative 1 and get negative 3 cosine squared of x sine of x. Or it could be negative 3 sine of x cosine squared of x. It doesn't matter which one, but the negative does need to be multiplied in the front. Okay, let's see. Okay, wait, I think I want it more like this. Okay, so let's go to some slightly more practice, some of which will be slightly different. Let's see how we do. That's too far bent. I was trying to make it so that I'm less likely to go off the page, but that didn't help. Okay, f of x equals e to the sine of x. What's the derivative? Well, hopefully we can see there's a function inside of a function. The inside function is sine of x. The outside function is e to the x. It's e to the sine of x. So the derivative of e to the x, this is e to the something, the derivative will still be e to the x with the inside function still plugged in. So e to the inside function times the derivative of the inside function, which is cosine of x. So e to the x cosine of x. E to the sine of x cosine of x. This should make sense, right? That if the derivative of e to the x is e to the x, the derivative of e to the sine of x is e to the sine of x, times the derivative of what was inside there. Okay, f of x equals x squared times cosine of 3x plus 2. Now this one is a little bit different. Now I'm going to go through it with you together. This time, this is not just an inside-outside function thing. I hope we recognize we cannot write this as f of g of x with just an inside function. Instead, what we should notice is that this is the product of two functions. So it's x squared times cosine of 3x plus 2. And so we're going to need to use the product rule here. The product rule says we do the derivative of the first one times the second one left alone, plus we leave the first one alone times the derivative of the second. Now this is where the chain rule comes in. When we do the derivative of this one, this is a composite function. There is an outside function and an inside function. The outside function is cosine of x, and the inside function is 3x plus 2. So this is going to be the derivative of cosine. So the derivative of this is going to be the derivative of cosine, which is negative sine, but with the inside function still plugged in. So negative sine with 3x plus 2 still inside of it, times the derivative of the inside function, which is 3. This first term can't be simplified. It's 2x cosine of 3x plus 2. But this second term, we can multiply x squared times negative 1 times 3 and get negative 3x squared. And then the sine of x, we can't mess around with anything that's inside of it. So there is our simplified answer. Okay, the next one. Oh, I like this one. Okay. Oh man, I wish I, well, okay. The next one. What is this a product rule? I see x multiplying times sine of x. Well, there is going to be a product involved, but this is clearly a composite function because this is all inside of this. So the outside function is just natural log of x. The inside function is x sine of x. And when we do the derivative of the inside, we will have to do a product rule here. Let's see how that works in just a second. So the derivative of the outside, the derivative of natural log of something is 1 over x, but we're going to leave the inside function still plugged in. So the derivative of natural log of x, the derivative of natural log of this is 1 over the inside function still inside of it. So the derivative of the outside with the inside function still inside of it times the derivative of the inside function. Now, when I do the derivative of the inside function, x sine of x is a product. And so when I do this, this is going to have to be the product rule, and I need parentheses here. The derivative of x sine of x, the derivative of the first one is 1 times the second left alone, plus we leave the first one alone times the derivative of the second. And again, with fractions, we always think of it as dividing by 1. And so we can multiply this onto the top. So it'll be 1 sine of x is just sine of x plus x cosine of x over x sine of x. So there we go. And there are some ways to simplify this that come out really nicely. Like you see how this is a monomial. There's only one thing. There's no adding or subtracting here. I could split this apart. Sine of x divided by x sine of x, the signs will cancel out and we'll get 1 over x. Here, x cosine of x divided by x sine of x, the x's will cancel out and it'll just become 1, and cosine over sine is cotangent of x. And so this one comes out nicely to like 1 over x times cotangent of x is like one nice way we could leave it. Last one, let's see how you guys do on this one. If f of x equals e to the tangent of x, what's the derivative? Well, this is the outside function is e to the something power. So the derivative of e to the x, the derivative of e to the something is still e to that something power, times the derivative of the inside one. The derivative of tangent, hopefully you have memorized, is secant squared of x, and that is our derivative. These get pretty quick. Once you've practiced it some, and you will have a long practice tonight. Once you practice it, this goes pretty quickly. Okay. How can we use the chain rule to get out of using the quotient rule? Man, you guys know I don't like using the quotient rule when I can help it. So one thing we can think of is that when you have a quotient, if you look at the denominator and you notice that it's just like something to a power, we can rewrite this. We can rewrite first as this is just to a negative power. Well, what's to the negative power? 2x plus 3 is to the negative third power. And now we can see we clearly have an inside function and an outside function, and we can do the chain rule. The derivative is what? Well, we have something to the negative third power, and the derivative of x to a power is we multiply by the power and lower the power by 1, and we're going to leave the inside function still inside of it, times the derivative of the inside function, which is 2. The derivative of 2x plus 3, this is a sum or difference. The derivative of 2x is 2, and the derivative of 3 is 0. 2 plus 0 is 2. And we can simplify this sum because we can do negative 3 times 2. That's going to be negative 6, and we can take this to the negative 4th power and move it to the denominator. So it's going to be 2x plus 3 to the 4th power. And notice that that works just like our power rules do. This power ended up getting lowered by 1, but we had to multiply times the derivative of the inside as well. Try this on your own. How can you rewrite this as a power rule? So I'm just rewriting it. This is not the derivative yet. How do you rewrite it? Well, this is 3 times something to a power. Clearly, the inside function is 4x minus 2. And what power is it to? Well, it was dividing, so it's a negative power. And it's a root, so it's a fraction power. And it's the square root, so it's the 1/2 power. So this is 3 times 4x minus 2 to the negative 1/2 power. And so what is the derivative? Well, we're going to multiply it by the power. So 3 times negative 1/2 is negative 3/2. You can just always multiply a whole number times the numerator. And then we will lower the power by 1. So negative 1/2 minus 2/2 is negative 3/2. So it'll be to the negative 3/2 power. And that inside function will still just be inside of it. We never change the inside function when we're doing the chain rule. We multiply times the derivative of the inside function, which is 4. 4 can multiply times negative 3/2. It's negative 12/2, which is negative 6. So we have, this simplifies to negative 6 because I multiplied these two together. This is a negative power, so it will go to the denominator. It's a fraction power as well, so it needs to have a root. It's the square root of the inside function, 4x minus 2 cubed. Okay. Whew. Tricky ones. All right, and I love these ones, guys. These are so easy to get right on the AP exam if you've practiced them some. So let's do some more practice with these table problems where they give you this weird function. So it says determine h prime of 3. Remember that for these problems, if they give you h of x equals this, before you start plugging things in, you always need to start by finding the rule for the derivative. So what is the derivative rule going to be? So it wants the derivative at x equals 3. First, we're going to find the rule for the derivative at any point. We're not even looking at this table yet. So the derivative is going to be, well, what rule do we need to use here? This is a product. So we need to use the product rule. It's the derivative of the first one times the second left alone, plus we leave the first one alone times the derivative of the second. Notice this is not a function inside of a function. These are two functions next to each other, which means they're multiplying times each other. Okay, and now we can find h prime of 3. H prime of 3 just means we plug in 3 for x, so this will be f prime of 3 times g of 3 plus f of 3, g prime of 3, and we can now use the table. So when x is 3, that's ugly. When x is 3, f prime of 3 was 3/2 times g of 3 is negative 4 plus f of 3, 7, and g prime of 3 is negative 1. So negative 4 times this is negative 12/2, which is negative 6, minus 7 is negative 13. So that's h prime of 3. Okay, how about this next one? H of x equals f of g of x. Determine h prime of 1. First, what is the formula for h prime of x? Hopefully you got it right, and you recognize that this is not product anymore because it's not f of x times g of x. This is f with what's inside of it. G of x is inside of it. This is a composite function. G of x is inside of f of x, so we need to use the chain rule. The chain rule says you do the derivative of the outside function, and you leave the inside function alone inside of it, times the derivative of the inside function. And this is literally the chain rule. This is what the chain rule was that we have on the front side of the page. If you have a composite function, the derivative is you do the derivative of the outside and you leave the inside alone times the derivative of the inside function. And so now what is h prime of 1? Well, h prime of 1 is going to be f prime of g of 1 times g prime of 1. And for composite functions, you always do what g of 1 is first, and then you'll do f prime of that. So this is f prime of g of 1. Let's look at the table. When x is 1, g of 1 is 3. So this is f prime of 3. This 3 is inside of f prime. times g prime of 1 is 1/2. And now we need to do f prime of 3. So we did g of 1, which was the inside function. And now we need f prime of 3. So f prime of 3 is 3/2. So 3/2 times 1/2, we just multiply across, is 3/4. Okay. All right, what about if h of x equals f of 3x? Do this one all on your own, find h prime of 1. So hopefully you started by finding what the derivative formula is. So the question is, what kind of a thing do we have here? Well, this is not a product. There's no two things multiplying. If it had said like f of x times 3x, this would be a product because these are multiplying. But instead, that 3x is inside of f of 3x. So this is a chain rule. It's a composite function. And so the chain rule says we do the derivative of the outside function. The derivative of f is f prime, leaving the inside function alone, times the derivative of the inside function. Okay? Now we can do h prime of 1. H prime of 1 equals f prime of, when x is 1, 3 times 1 is 3. So we're going to be doing f prime of 3. Man, we've done f prime of 3 a lot of times. F prime of 3 is 3/2 times 3. And when you multiply a fraction times a whole number, you just put the whole number over 1 and multiply across. So the whole number always just multiplies times the numerator. So 9/2. Okay, last one, guys. Let's see how you do on this one. H prime of 1. Go ahead and try it. And hopefully you started by finding the derivative formula. I see a sum or a difference, so I'm just going to do each one of these separately. So the derivative of 3x to the 4th, this is power rule. We multiply by the power, lower the power by 1. Here, we've got, this is something squared. G of x is being squared. So here, the outside function is x squared, and the inside function is g of x. So it's g of x being squared. So hopefully we feel comfortable saying that g of x is being squared. And because it's a function inside of another function, this is a composite function, and we need to do the chain rule. So it's going to be 2 times just x, but the x is the inside function. So 2g of x times the derivative of that inside function, which is g prime of x. Minus, now we're going to do this third one. This is a constant multiplier times a function, so we leave the constant multiplier alone and do the derivative of the function. So that's h prime of x. So now we can do h prime of 1. H prime of 1, 1 cubed is 1, so 12. Here we're going to have 2 times g of 1 times g prime of 1 minus 3 f prime of 1. So let's use the table to evaluate these. G of 1 is 3. 2 times 3. And g prime of 1 is 1/2. Minus 3 times f prime of 1 is 5. So we get 12. A half times 2 is 1. That's the easiest. You could do 6 times a half and get 3, but it's easier, I think, to recognize that you've got half of 2 is just 1 and 1 times 3 is 3. But, you know, do whatever fraction skills you like there. Minus 15. 12 plus 3 is 15. 15 minus 15 is 0. So h prime of 1 equals 0. Now, what does it mean that h prime of 1 equals 0? What does that mean for the function h of x? We don't even know what h of x looks like. H of x is some crazy function, but I know that because h prime of 1 equals 0, that means when x is 1, we don't know what the y value is, although we could probably find it. The slope is 0. That means there's a horizontal tangent line. So maybe it's looking like this, something where it's flat for just a second, where it's not increasing or decreasing. All right, let's do this with some applications of the things we like to do, the kinds of derivative questions we like to ask. How about determine f prime of x? Okay, well, that's pretty straightforward. What are we going to do here? What is f prime of x? Well, hopefully we recognize that this is a chain rule. There's something inside of sine, so it's sine of something. And the derivative of sine of something, the way the chain rule works is we do the derivative of the outside function, cosine, with the inside function still inside of it, times we do the derivative of the inside function. And I'm going to make a mistake here that I see kids make sometimes, and I want you guys to tell me why you would get no points on this on your test. What is wrong with this? And hopefully we recognize that the problem is that this needed to have parentheses. because we're multiplying times the whole derivative, and this is a binomial. Whenever we have a binomial multiplying, we need to put it in parentheses. Okay. If y equals 1 over x cosine of square root of x, determine dy dx. Okay, what's it asking us to do here? Well, this is just finding the derivative. I know I need to rewrite this first. So this is y equals x to the negative 1 power. So I can actually do the power rule. So y prime will be, I multiply by the power. I lower the power by 1. This one is going to be, well, what's the outside function? This is square root of something, and that something is cosine of x. So the derivative of square root of x, hopefully we've memorized by now. Again, it'll save you a lot of time if you do. But if not, the square root of x is x to the 1/2 power. The way we do the derivative is we do 1/2 times x to the, we lower the power by 1, so minus 2 over 2. That'll be negative 1/2. And we can rewrite this as 1 over 2 square root of x. Now, in this case, the thing that's inside of here is an x. It's cosine of x. So it's going to be 1 over 2 square root of cosine of x times, so that was just the derivative of the outside function with the inside function still inside of it, times the derivative of the inside function. And the derivative of cosine is negative sine of x. So this is negative 1 over x squared. Whenever we have a fraction, we can multiply this on top, and it's a negative times a positive, so we'll put minus sine of x over 2 square root of cosine of x. So some hard ones here. These do get a little tricky until you've practiced it some. If you're missing some of these, don't feel bad. Sometimes they take a little while to get used to. Okay, evaluate the derivative at the point 2, 4. So this is s of t, so t is 2, and when t is 2, obviously we get 4 here. I don't know, we could do it. Square root of 16 is 4, sure. Okay, so how do we do the derivative? Well, s prime of t equals, this is an inside function, so again, we've got square root of something, and you can do it as x to the 1/2 power and actually do the power rule, but I hope you're starting to memorize what the square root one is, and I'm going to show you how that looks. It's just 1 over 2 square root of whatever it is. So 1 over 2 square root of the inside function. So hopefully we recognize that the derivative of square root of x is 1 over 2 square root of x by now. But if not, you might want to take a few minutes just to memorize this. It's worthwhile. You can do it the power rule way, but it's worth memorizing because it comes up a lot. Okay, times the derivative of the inside function. And again, this has to be in parentheses because there's going to be a binomial. 2t plus 2. I hate it when there's t's and pluses next to each other. And of course, this can go on top. So this is 2t plus 2 over 2 square root of t squared plus 2t plus 8, but that was not the question. It asked us to evaluate it at the point 2, 4. So here, t is 2, and the y value is 4. So when I plug in t is 2, we're not plugging in 4, we're plugging in the t value, the x value, or the t value. And when I plug in 2, 2 times 2 is 4, plus 2 is 6, over 2 square root of, 2 squared is 4, 2 times 2 is 4, 4 plus 8 is 16. So this is 6 over 2 times 4, which is 6/8, which is 3/4. And again, what that means is there's this weird square root function, whatever it looks like. I'm not even sure, but I do know that at the point 2, 4, the slope is 3/4. So it looks something like this right there. I don't know what the curve would probably look something like this if I had to guess. I don't know. But the slope at 2, 4 is 3/4. Remember, the derivative is telling us the slope. All right, last one for the day. Determine the equation of the line normal to f of x. Hopefully we remember from geometry that normal lines are lines that are perpendicular to a curve. So this is a normal line. It makes a right angle with the curve. Specifically, it makes a right angle with the tangent line. So normal lines are perpendicular to the tangent line. And so since calculus tells us about tangent lines, it can also tell us about normal lines. In calculus, the slope of the tangent is f prime of x. And so the slope of the normal line will be, well, how do we find the slope of a line that's perpendicular? It'll be the negative reciprocal of whatever the slope of the tangent line was. So we'll find the slope of the tangent line by finding the derivative, and then we'll do the negative reciprocal, and that will be the slope. And to find the equation, we need the slope, and we need a point, and this will give us the slope. We find the slope of the tangent line, and then we use our geometry to know that normal lines are perpendicular. So with that in mind, find the equation of the normal line. Hopefully we recognize that we need, for an equation, we needed a point. So we've got the point 1 comma, let's see, 3 times 1 minus 2 times 1 is 1. 1 to the 5th is 1. So we have a point 1, 1. And we need to find the slope of the tangent line so that we can actually find the slope of the normal line. This is something to the 5th power. So the chain rule applies. This is an inside function to the 5th power. It's going to be 5 times that inside function to the 4th power. So we multiply by the power, lower the power by 1, leave the inside function alone inside of it, times the derivative of the inside function. This has to have parentheses because when I do the derivative, there will be a sum or difference, and so it'll be a binomial. The derivative of 3x squared is 6x minus 2. The derivative of 2x is 2. And so I can just plug in 1 for x. So the slope of the tangent line when x is 1 is 5 times, when I plug in 1 here, I get 3 minus 2 is 1 to the 4th power. 6 times 1 is 6, minus 2 is 4. And so I get 5, 1 to the 4th is 4, or 1 to the 4th is 1, 5 times 1 times 4 is 20. This is the slope of the tangent line. So, you know, at 1, 1, the slope of the tangent line is super steep. The slope of the normal line will be perpendicular to it and will be super flat. So the slope of the normal line negative 1/20th. Okay, so the equation of the normal line, well, we need the slope and a point, and both the normal line and the tangent line intersect at the point that's on the function, so we can use that same point for both the tangent line and the normal line. The slope of the normal line is y equals negative 1/20th times x minus 1 plus 1. The slope of the tangent line would have been y equals 20 times x minus 1 plus 1. And we will stop there for today, guys. You'll get lots of practice on this stuff. Hopefully you're feeling pretty good about it. I hope you guys have a great rest of your day.